We are on the way to solve questions based on Euclid's division algorithm and fundamental theorem of arithmetic. In last session, we solved first question. It took too much time. Now we will solve upcoming questions. We have to find the HCF and LCM of 6 and 20 using prime factorization method. 6 can be written as 2 into 3 and 20 as 2 into 2 into 5. All of these numbers have hidden power 1. That means if a number has no visible power, it says its power is 1. Its HCF is 2 because 2 to the power 1 is common in both factors and no other number is common. Now we will find LCM. So 2 to the power 1 is 2 times in the prime factors of 20. That means we can write it 2 square because in such case we add the powers. For example, here 1 plus 1 is 2. So we have to find LCM. To find the LCM, we see how many numbers are present in both factors. In this case, we have 2, 3 and 5. Now we take a number whose power is greater. In this case, we have 2 in both factors and 2 square is greater, so we will take it. Again the next number is 3 and it is also single. That means whatever will be its power, it will be considered as greater. So we will also take 3. Again 5 is one time and it is also single, so we will take it. 2 square will be 4. 3 and 5 can be written as it is. By multiplying them, we will get 60. This is the LCM. Next question. We have to find the HCF of 96 and 404 and also the LCM. Let's find the prime factors of 96. We will divide it by 2. 9 is divisible by 2 4 times and leaves remainder 1. So the next number will be 16, which is divisible by 2 8 times. Again 48 is divisible by 2 24 times. And 24 is divisible by 2 12 times. And 12 is divisible by 2 6 times. And 6 is divisible by 2 3 times. Now 3 is a prime number, so we can't divide it. So we will stop the division. Let's find the prime factors of 404. We will divide it by 2 and get 202. And 202 is also divisible by 2 and we will get 101. Now 101 is a prime number, so we will stop dividing this number. So these are the prime factors of 96 and prime factors of 404 is 2 into 2 into 101. Now 2 is common in both factors. Also another 2 is common in both factors. That means HCF is 2 into 2, which is 4. Let's find LCM. First of all, we will see how many numbers are present in both factors. There is 2 and it is many times. Also we have 3 and 101. Now 2 is 5 times, so we can write it as 2 to the power 5. Also 3 is only one time, we will also write it. 2 is 2 times in prime factors of 404, it can be written as 2 square. And 101 is only one time, so we will also write it. Now 2 to the power 5 and 2 square are present in both factors, but 2 to the power 5 is greater, so we will take it. Now 3 is the next number, which is only one time, so we will take it. 101 is also one time, so it is greater, we will take it. 2 to the power 5 can be written as 32 because multiplying 2 5 times by itself gives 32. By multiplying all these numbers, we will get 9696. That means we found LCM. Let's see next question. This time we have 3 numbers and we have to find their prime factorization. So we have 6, 72 and 120. 6 is 2 into 3. We have taken the prime factors of 72. Also we have taken the prime factors of 120. Now we have to find out their HCF and LCM. 2 is common in all these 3 factors, so we will take it. Also 3 is common, so we will take it. And 2 into 3 is 6, so HCF is 6. Let's find out LCM. So 2 is available in all these 3 factors. So now we will see which power is greater in all these 3 factors. So here we have 2 3 times. Also 2 is 3 times beneath it. So 2 cube is available in both factors. That means it is greatest. So we will take it. Again we see 3 is available in all these 3 factors. But here we have 3 2 times. That means we have 3 square, which is greatest between all. So we will take it. Now next number is 5 and it is exactly one time. So we will take it. We have taken all available numbers and we got 2 to the power 3 into 3 square into 5. 2 cube be 8 and 3 square be 9. By multiplying all these numbers, we will get 360. This is the LCM. Next question, we will solve question 1. In this question, we also have to find the HCF and LCM using prime factorization method. Here HCF means highest common factor. It is also called greatest common divisor. Now tell me, what will be the HCF of 12, 15 and 21? Common factor or divisor is a number which divides all the given numbers. And the highest common factor means the largest number between all the divisors of the given number. So 12 is the smallest between 12, 15 and 21. That means each factor which will divide these three numbers will always be smaller than or equal to 12. And that number will divide all these three numbers 12, 15 and 21. So here we have taken all numbers smaller than 12 and included 12 also. Now if you see, 3 is only the number which divides all these three numbers 12, 15 and 21. That means all these numbers are present in the table of 3 and no other numbers are dividing 12, 15 and 21 completely. That means our HCF is 3 because it is only the greatest divisor which divides all these given three numbers. Now we will find LCM. This time we won't use prime factorization method to find LCM. We will see other perspectives so that we can have better understanding of least common multiples. Here we have taken the table of 12. We have taken its multiples more than 10 times, which we take in simple tables. In the same way, we have taken the tables of 15 and 21. Now can you find any number common in all these three tables? Take some time and find it. If you see, 420 is common. Now you should look for another common number. It may be present. Here 840 is also common. So we have taken the multiples of 12, 15 and 21. 420 and 840 are common. That's why these two numbers are called common multiples. And also 420 is the smallest common multiple. There is no common multiple smaller than 420. That's why 420 is called least common multiple. So we found out LCM. Let's jump to next question. We have 17, 23 and 29. If you notice, all of these are primes. That means they have no common factors. In this case, HCF will be 1. But why 1 is the highest common factor? If we have given minus 5, that tells this is the negative 5. But if we remove minus sign, then we will have only 5. It is not only 5 but positive 5. If there is no sign in front of 5, it is considered that plus sign is hidden there. That means if a number has no sign, then by default we always have plus sign. It's an obvious thing. In the same way, when we find the HCF or we can say GCD of numbers and there is nothing common between them, then by default 1 is considered as HCF. Now you can also say we can obviously include 1 as a factor in all these numbers. Then why we are talking about this useless stuff? And in this way we can find 1 as HCF. It's a good thing and you can do so. But wait a second. Do you think everything is fine? There is no mistake? Then you are wrong. Be careful, we are finding HCF using prime factorization method. That means we must take only prime numbers as factors, and here you have included 1, which is not a prime number. And we have already understood why 1 is not a prime number. We discussed about it in fundamental theorem of arithmetic. Therefore, 1 is not a prime number, so we can't write it as a prime factor here. And obviously, you can say 1 as a factor or divisor, but never say it a prime factor. Now we will find their LCM. In this case, there is no need to do anything. Just multiply all these three numbers together. And the product you will get will be the LCM of these numbers. That means 11,339 is the smallest number which is divisible by all of these three numbers 17, 23 and 29. But how is it possible? We just multiplied the given three numbers and got the LCM. Let's understand it by some small numbers. We have taken 2, 3 and 7. All these three numbers are primes. So their LCM will be 42. Now 42 appears in the table of 2 in 21 times. It appears in the table of 3 in 14 times, also appears in the table of 7 in 6 times. You could not find any number smaller than 42 which appears in the table of all these 3 numbers 2, 3 and 7. So the prime factorization of 42 is 2 into 3 into 7. That means 2 is a divisor of 42 and also 3 and 7 are the divisors of 42. And this is the reason why we multiply the given prime numbers to get their LCM. Let's jump to the next question. This question is similar to the last question, but these 3 numbers are composites. So here we have taken the prime factorization of 8, 9 and 25. You can see there is nothing common in all these 3 factors. So their HCF will be 1 by default. Now what will be their LCM? So we have 3 factors in all these 3 numbers, that is 2, 3 and 5. So we will take the number which has greater power. So 2 is 3 times and hence we will take 2 cube. We can write it as 2 into 2 into 2. Also 3 is 2 times, so we will take it, and we will take 5 2 times. If you see, we have just taken 8, 9 and 22. We get 1800 by multiplying them. That means their LCM is 1800. Next question. Again we have to find the HCF and LCM, and then we have to verify whether the product of LCM and HCF is equal to the product of the given 2 numbers or not. We have already learned about this formula in Euclid's division algorithm concept. Let's see first question. 26 can be written as 2 into 13 and 91 is 7 into 13. So we have taken their prime factorization. So 13 is common in both factors. That means HCF will be 13. Let's find LCM. So its LCM will be 2 into 3 into 13. We will take 13 only once because 13 is available in both factors and its greatest power is 1. We will get 182 by multiplying all these 3 factors. So the LCM is 182. Now let's multiply both HCF and LCM. So LCM is 182 and HCF is 13. We will get 2366 by multiplying them. Let's assume it as equation 1. Now let's find the product of these 2 numbers. We have 2 numbers 26 and 91. We will get 2366 by multiplying them. Let's assume it's second equation. Now you can see equation 1 and equation 2 are equal. That means the product of HCF and LCM is equal to the product of given 2 numbers. So we verified our question. Let's see second question. Dividing 510 by 2 gives 255. Let's check whether this number is divisible by 3 or not. We will get 12 by adding all digits of 255, which is divisible by 3. That tells 255 is also divisible by 3. So 25 is divisible by 3 in 8 times and leaves remainder 1. So the next number becomes 15, which is divisible by 3 in 5 times. Now we have 85, which is not divisible by 3. And 5 divides it in 17 times. Now we will divide 92 by 2 to get the prime factors, and we will get 46. And 46 is divisible by 2 in 23 times, and 23 is a prime. So now we will stop dividing this number. Now 2 is common in both factors and nothing else is common, so the HCF will be 2. So now let's find LCM. 2 is available in both factors, but 2 is 2 times in factors of 92, so it is greater. Therefore we will take 2 square from here. Now next number is 3, which is only 1 time, so we will take it. 5 and 17 are also available only 1 time. We will also take them. 23 is also present in the factors of 92. We will take it. After multiplying them, we will get 23460. Now let's see what is LCM into HCF. So LCM is 23460 and HCF is 2. And the product of these 2 numbers is 46920. Now let's see what is the product of these 2 numbers. First number is 510 and second number is 92. After multiplication, we will get 46920. So we also verified them. Let's see next question. This time we have 336 and 54. I think now you are able to solve this question. You will get HCF 6 and LCM 3024. Let's see next one. First of all, we will understand this question and then solve it. We have given the HCF 9 of the numbers 306 and 657, and we have to find out their LCM. So we have already understood that the product of HCF and LCM is always equal to the product of given 2 numbers. And if you don't know about it, just see Euclid's division algorithm concept, everything will be clear. We have proved this formula in an easy way, and now we will use this formula to find the LCM of given two numbers. We don't know what LCM is. So let's consider LCM as x. Therefore, we will put x in place of LCM. HCF is 9, which is already given. So we will take it. Now 306 is first number and 657 is second number. So we will multiply them. We have to find out the value of x now. So we will divide both sides of the given equation by 9, and hence our equation is balanced. Now we can divide 9 by 9, and on other side we will divide 306 by 9. So 30 is divisible by 9 3 times and leaves remainder 3, which will be added to the next number. So 3 will be added to the next number 6, and now we will get 36, which is divisible by 9 in 4 times completely. Therefore, we got x in LHS and 34 into 657 in RHS. By multiplying them together, we will get 22338, and this is the LCM. So we found LCM using Euclid's division algorithm. We can also get LCM using prime factorization method. We will find the prime factors of 306 and also find the prime factors of 657. You will get 22338 doing it by yourself. Hence, we can find the LCM using both methods. Let's see next question. We have to find out the HCF using Euclid's division algorithm. Let's see first question. So 135 is smaller than 225. Therefore, we will divide 225 by 135. We already know how to find the HCF using Euclid's division algorithm. You can also watch that video in which I have told everything about it. So 225 is divisible by 135 in one time. That means we will get 135, which will be subtracted from 225, and we will get 90. We can also write this step as an equation. So remainder is still not 0. So we won't get HCF. This time we will divide 135 by 90. Again 135 is divisible by 19 in one time. So we will subtract 90 from 135 and we get 45. We can also write this step as an equation. Still remainder is 45, but we have to reach 0. This time we will divide 90 by 45. And this will be divisible by 45 in 2 times completely, and the remainder becomes 0. This step can also be written as an equation. We found 0 as a remainder, so 45 is the divisor at this step, and this will become the HCF. This can also be found out using prime factorization method. Here we have taken the prime factorization of 135 and also have taken the prime factors of 225. 3 is common in both factors, another 3 is common, and also 5 is common. By multiplying all these 3 factors, we will get 45. And hence we found the HCF using prime factorization method. Let's see next question. 30 at 220 will be divided by 196. Since 196 contains 3 digits, that's why we will take only 3 digits from 38220 to divide it. If we divide 382 by 196 in 2 times, we will get 392, which is greater than 382. So we cannot divide it in 2 times. So we will divide it only one time by 196. So we will subtract 196 by the given number and we will get 186. Now we will divide 196 by 186, which is divisible by it in only one time. Wait a second, is there everything alright? What do you think? I think we are making some mistake. Let's see how. So we have divided 382, but still we have 2 digits left undivided, which is 2 and 0. We did a big mistake right now and you didn't even notice it. In this way you cannot master mathematics. You must be always active while solving a problem, otherwise you will get into a big trouble in examination. If you made a small mistake during calculation, you will destroy the whole answer. That means if you are solving a question and you accidentally used plus sign instead of minus sign, that single mistake will be enough to ruin the whole answer. You will get 0 marks on that question. So be careful. Don't make such mistakes. So here we will not take 196. Now we will put 2 from above and we will get 1862. Now 196 multiplied by 9 gives 1764, and when we subtract it we get 98. Still 0 is remaining above. we will take it, and now we have 980. This time we will multiply 196 by 5. We will multiply 6 by 5 first and we'll get 30. 0 can be written here and we will keep 3 to add it to the next number. This time we will multiply 9 by 5 and product will be 45. So we will add 3 in 45 and we'll get 48. Again we will write 8 and keep 4 to add it to the next number. This time we will multiply 1 by 5 and we will get 5. Now 4 was kept to add, so we will add it, so we get 980, and 980 minus 980 is 0. Now we have to divide 0 by 196. This is the right way according to Euclid's division algorithm, but here we found remainder as 0, which tells that 38220 is completely divisible by 196. So 196 is the factor of 38220. Also 196 is the factor of 196 itself. That's why 196 will be the HCF of given numbers. Let's see next question. We will divide 867 by 255. When we try to divide 867 4 times by 255, which is greater than 867, so we will divide this number in 3 times. So 3 times of 255 is 765, and by subtracting it we will get 102. Since remainder is still not 0, this time we will multiply 102 2 times and we will get 204. Now by subtracting it we will get 51. So we will divide 102 by 51 and we see it is completely divisible, and now remainder is 0 and hence our HCF will be 51. This question is done. Let's end this session. See you soon in next class.